Good morning, guys, and thank you so much for coming out today. I'm Amanda Baranauskas.
And I'm Dean Sarantino.
And we're from Putnam Investments located in Boston, Mass. And as Peter mentioned, today we're going to talk about how Putnam visualizes survival analysis and explores what-if scenarios. So for the next hour, we're going to do a brief introduction of who we are, what we do at Putnam, and then we're going to dive right into a business problem. So kind of walk through a case study that was presented to our group. In order to solve the case study, we used a statistical approach called survival analysis. So you'll see we have a short crash course on what survival analysis is. And then we're going to go right into a live demo of building and visualizing the model and talking about what you can gather from the what-if tool. And then we'll leave time at the end for any questions you may have. So Putnam Investments is a mutual fund company. As I said, we're located in Boston, Massachusetts. We have over 80 funds. We've been in business for over 75 years with $148 billion in assets. Dean and I work in a group called Analytical Services. We fall under the operations umbrella. So we're doing data management, analytics, and data science for all of operations. We work with the call center, the processing department, sales and marketing, finance. So really a whole wide array of things that we're doing. I'm a senior operations manager. I've been with the company for 10 years. This is my 4th Tableau conference, and I've been using Tableau for about 5 years.
I've been at Putnam for 2 years, using Tableau the whole time for analytics and data science projects. This is my 2nd Tableau conference, but my 1st year presenting.
So moving right along, on the slide next to me, you'll see the business problem that was presented to us. So of the assets on the books today, how much do we expect to retain at the end of a given period? So this is something that finance came up to us and said, we know over time that we lose money, we lose assets, we lose customers. We have all this data about customers who have left the firm, or we know how long customers have been with the firm. How can we put that together to try to figure out some assumptions and some expectations on what we can have at the end of 1 month, or 3 months, or 1 year? I know most of you, or many of you, may not work in the finance industry, so I challenge you to think about this in your own industry. So instead of assets, think about your customers or subscribers or units of a product that you're selling. You know that over some time, those are going to go away. Using the data that you have, how can you come up with some expectations or predictions about what you're going to have at the end of 6 months or a year? To take this a step further, it's great to know in total, but there's other factors that go into that customer behavior. So we wanted to build out a model that we could look at how different funds or different firms may play into this customer behavior or customer age. So think about your own industry, think about some factors that drive customer behavior and how you can apply this knowledge to what you're doing.
Yeah, so this is actually a really interesting problem that we faced. So we have kind of a generic definition of survival analysis, if you're not familiar with it, on the board, but really there was something kind of unique about our data, something that made this a better approach than maybe just using regression like OLS or some sort of machine learning model, in the sense that we have this thing called right censorship in our data. So sometimes people purchase shares of a fund and they hold on to it, and we never see them take their money out, and at other times we do. So really we have some sort of duration in our data, how long the assets have been with us, but additionally we have some information of are they still with us or not, and that kind of should impact our analysis. So survival analysis was kind of a natural fit for this. It's a kind of a whole basket of statistical approaches that works really well with censored data, especially right censored data. So what we're focusing on is really the time until some sort of event. In our case, the event is this redemption activity, people taking their money out of a fund. But I mean, classically, survival analysis deals with like death. If you have patients that have a disease, what is your expectation 12 months out on how much of the population will still be alive? It can work with subscribers if you offer a service, things like that. So yeah, that's kind of the motivation behind the approach. So I don't want to get too bogged down with math and notation and stuff, because I don't really think that's our focus. But I do think it's important to get some context around what we're going to be doing. The important takeaway from this slide is that we'll be using Python to really worry about the first two functions, and then we'll use Tableau to calculate the third function, and that will give us a lot of flexibility. It'll make it so we can kind of leave the Python world. We don't have to code anymore, and we can just kind of play with the model in Tableau. So we'll quickly walk through these. First is the hazard function, which is the likelihood of an event occurring in each time period. So we want to know 1 month out, 2 months out, what's kind of our risk of someone taking their money out of a fund. So if we accumulate that risk over time, kind of like a window function, or if you use like a database, like an analytic function, a rolling sum, we'd get the cumulative hazard function. So if you do a lot of survival analysis, maybe at like the academic level or something, you really work with this function a lot. Kind of the problem we had is it's really tough to describe to the business what accumulated risk over time or something like that might mean. So that's really what's important about the survival function. It tells us the likelihood of survival beyond time period t, where if t is 0, that's the same month that they purchased the shares. T equals 1 is 1 month out from that, and so on. So that's kind of how we'll be, kind of what we'll be working towards. So at this point, we're going to jump into a demo. So I'll show you guys some generic code in Python that could get you started applying this at your own company. And then we will move to Tableau and start visualizing the model and have some fun with it. So if you work with Python at all, you're probably familiar with this this kind of setup. It's a Jupyter notebook that I just exported as an HTML file. I should preface this by saying all the data is purely fictional, everything's fake. We couldn't share real data, but I really don't think it takes away from anything. I think you'll still have plenty of information to kind of hit the ground running with this stuff. So I'll jump through kind of block by block of the code so you guys can just really understand what we're doing, so things kind of make sense when we move on to Tableau. So in the first block, we're just kind of importing stuff we're going to use. CX Oracle to connect to our Oracle database, Pandas and NumPy for data manipulation, OS just to join path names. The important one is Lifelines. That's a survival analysis package in Python that we're going to use. Some really good documentation on the web of getting started with this package too, so I'd encourage you to check that out. And Patsy, which is what we'll use to make the design matrix, so getting our source data in a format that'll work with the Lifelines package. So in this next block of code, pretty basic stuff. We're just pulling all of our generic data from a table in Oracle and reading it into a Pandas data frame and outputting kind of this nice HTML table. So looking at this, we can get a sense of what our source data looks like. Each record here represents a purchase event. So looking at the first record, we could see that a customer purchased through San Antonio Advisors. So we don't do a lot of business directly with customers. Customers go through brokers in our case. So we can see what firm that is. We can see what fund they're purchasing into. So we have kind of like fun Texas-themed fund names. We can see the age of the customer. So these kind of three things are things that we have in mind that we're going to use as regressors in our model later. And as I mentioned earlier, we need some sort of duration, how long those assets have been with us, and some sort of representation of the event, where 1 represents that we did observe the customer take their money out of the fund, and 0 represents that they did not. So that first record, we did observe a redemption. On the second, we did not. Moving along, this is where we use Patsy to make our design matrix. So we specify our regressors that we just talked about. We're going to rename duration to T to represent time to event, and observe to E to represent event. and output this. So one nice thing about this, if you've ever done like encoding of categorical variables for a regression or something, it kind of does this automatically, which can save a lot of work. So everything's in the right format. So notice that this is a very small example. We only have a few records of data just to kind of illustrate what the code would look like. So now we're passing that data frame into our model. And you'll get this like loading bar to show the progress. And we're going to rename our columns so we don't have ugly Python column names anymore. We have stuff that kind of makes sense to the business. And now we're displaying the cumulative hazards. So it's not really important for us, for the purpose of this talk, to understand what the implications of this cumulative hazards table means. The important takeaway is this is what we're going to load into Tableau and what we're going to use for our survival function. So in this last block of code, we're just specifying a path that we're going to dump the CSV, and we're going to output it, basically. So with that, we have everything we need to kind of get started in Tableau. So we have just kind of blank instance of Tableau. And we have our data file that we just made. We're going to drag it in. So you'll notice that pretty much everything loaded in fine except this column, which represents our, you might see it called timeline or something. For us, it's really months out. This represents how many months out from the initial purchase we are. So we can rename that to months out. And you'll also notice that this doesn't take up a whole lot of space. It's pretty small. It's only 12 records. You'll have a lot more records if you have like very non-integer time levels, basically. If you're looking at 12.17 months and stuff like that, you'll see a lot more records. But just kind of for this dummy example, it's really small. But it shows that you can do a lot with a pretty small amount of data after you do a lot of processing in Python. But yeah, so now we're ready to start visualizing the model. The first thing we want to do is we want to show months out on the x-axis. That's kind of the standard approach we want. We want time on the x, and we're going to want survival rate on the y-axis. So first thing, we'll move months out to dimensions and move it to columns. So that looks pretty good. Everything's displaying how we'd expect it. And as I mentioned, now we want our survival function. But if you look at our measures, we don't really have that yet, so we have to build it. So we can open a calculated field and call this survival. And we can start building our calculation, but we really don't have everything we need to build it kind of the way we'll want to build it. So if you think back to our initial formula, we don't have to really have it memorized. We had e to the negative cumulative hazard at each time point. So since we have these kind of regressors in our model, they each have a contribution to the total cumulative hazard at each time point. So we need to kind of group those together. So, I mean, if you're familiar with regression, this is kind of like your intercept term, your baseline. And now we want to add in maybe the cumulative hazard we'd expect from purchasing through a specific firm or a specific fund. And the problem we face here is sometimes we want the cumulative hazard for the Bonnie and Clyde tax-exempt fund, for example. Sometimes we want the Cowboy fixed income fund. So what we need to build is a way to dynamically select these things so the proper cumulative hazard is kind of put into this calculation and we're getting the appropriate curve. So given that, we should really pause on this calculation. We'll just hit OK and leave it with a exclamation mark while we kind of build the rest of the things we need. And the way we did this is kind of starting with parameters. So the first one you might guess we need is we need a fund parameter. And of course, our fund names are strings. And we should put these in as a list. So to kind of save some work, we already have these typed out, so we can just kind of paste them in. Paste from clipboard, so everything looks good. We need to make another parameter for firm. It's our other categorical regressor. Oops. Also string. And hit OK. And we also need a parameter for customer age. So this one isn't categorical. This is one of the continuous variables in our model. So we'll create one more. And we'll call it age of customer, so we're not confused with our customer age measure we already have. And this can be an integer. We're not too worried about things between whole numbers. And what you might want to do here is put a range in. We don't see too many 2- and 3-year-old investors and things like that, so you might want to, I don't know, create some boundaries between maybe 18 and 85 years old. Hit OK. So we're one step closer to getting the survival function built, but we can't just kind of drop in a string that says our firm name or something like that. What we really want is we want this parameter to drive some other calculation, which we'll put in our survival calculation. So we're really just a few more measures away. So first we'll make one for fund. I've been calling these fund switch. You can call it whatever you want. I'm just naming it like this so I know that parameter is driving this. We're going to do this with basically just a case statement. And we have this kind of pre-written, but we'll walk through it. So we're going to say case, whatever our parameter for fund is. So in this case, it's just called fund. When it's this Bonnie and Clyde tax-exempt fund, then we should use the appropriate contribution to cumulative hazard. When it is this other fund, Cowboy Fixed Income Fund, should use that one. And for Spurs Equity Fund, we should use that one. So everything looks good. This is just what we need for our survival function, so we can move forward with this. As you might expect, we need an almost identical one for firm. So we'll remain consistent with our naming. And jump back and put this one in. So case when the firm parameter is Houston Securities, we should use that contribution. For San Antonio Advisors, we should do the same. And we run into kind of not a problem, but kind of something that might trip you up with Dallas Capital Group. So if you've ever encoded a categorical variable, you'll notice that you'll kind of get one less field for the number of values you have. So really, the effect of Dallas Capital Group is already included in our baseline. So there's no marginal effect here. So this should just be left at 0. So at this point, this parameter is exactly what we need for our survival function. And we need one more for age of customer. So we'll call this customer age switch. And this will be age of customer times customer age. And we can hit OK. So at this point, we have what we've kind of been working towards. We have these what we called switch measures that we're ready to plug into the survival function so that when we kind of play around with these parameters, the calculations will be adjusted accordingly, and we can generate survival curves for all sorts of different scenarios instead of just kind of a static curve that's overall or something like that. So we can edit this survival function that we started. So we have e to the negative, and now we need to add up all of the cumulative hazard. So we still have our baseline, but we should also have the fund switch, the firm switch, and what do we call it? Customer age switch. So this kind of formula is, or this approach is specific to the ALIN additive model. That's the one we chose for this presentation. So the steps you'd go through would be different for a different kind of survival analysis method, but this is what we do for using that model. So we can hit OK. And remember, we want this on the y-axis. So if we drag this to rows, we should get that if all went according to plan. And we have a function. So before we get too excited with this, it's easy to see your survival function. You're ready to go with it. We don't really know what this represents, right? We're not looking at our parameter values yet. This could be for any firm. This could be for any fund. So the first thing we want to do is show this stuff so we know what we're looking at here. All right, so we've basically generated expectations for assets purchased through Houston Securities into the Bonnie and Clyde tax-exempt fund for an 18-year-old investor. What's great is we'll be able to change these, and that's what Amanda will show in a minute, and how we can see how our expectations will change as these regressors change. But before we do that, before we pass it off to the business, there are a few more things we should do to kind of clean things up and make things a little more clear. So the first thing that we can do is really this axis should be between 0 and 1. We don't want it to resize because we want, if the expectations are really low for one fund or really high for another, we don't want the axis to rescale and then the curves look identical. And of course, this is between 0 and 1 because you can never have more of the population at some point in time than you started with. We're only looking at how some initial quantity decays over time. I mean, it's a bit abstract in finance, but if you think about if you're observing deaths, people don't typically come back from the dead and things like that. So it's pretty intuitive. Additionally, we found that it's a little easier to look at this when it's expressed as a percent instead of just as a decimal. So we can change the default property to percentage. We don't really need decimal places. And there's really still more we can do here. A small one is that typically we wouldn't really view this as a bar graph. We're looking at change over time, so maybe a line graph is more what people would be expecting. But it's still kind of tough to read. Now you're stuck explaining to your business about percentages and things like that. What would be really powerful is if they could plug in some amount of sales or something like that. So if they had a bunch of purchases come in and they totaled $1 million, how does that $1 million decay over time? And really, that's a really easy step since we've done all this. So we can go ahead and build that and see if that adds some clarity to our model. So we'll want another parameter for that, and we can call this, something like initial investment. I think integer's fine. And we don't really need to impose any sort of range on this. We might want to change the format of this to currency, kind of ignore decimal places. And we can show this parameter. So it's at $1 for now. That's can set it to 1 million, but it's not really tied to anything yet, right? We can't really do anything with it. So what we'll want to do is create another measure that's essentially survival times this initial investment. and we can call this something like dollars remaining. Hit OK. We definitely want this to be currency as well, because we're talking about dollars. And we can bring this onto the label. And now we can see that dollar change over time. So as kind of a last step before we pass things off, we might want to name this. So we could call this asset survival analysis. And this looks pretty good. So at this point, I'm going to hand it over to Amanda, and she can show you how, kind of from a business user perspective, how they kind of get insight out of a tool like this.
Thanks, Dean. So let me put this into presentation mode so you can see it a little bit clearer. So this is a great example of something that we've done where our group has built it, and then we hand it off to the business so they can start to make their own assumptions and really dive into the data. What we have here is a what-if tool that allows them to flip between these parameters and really see the changes between their covariance and how these affect their underlying data. So looking at what we have here, we have $1 million invested into Houston Securities into the Bonnie and Clyde tax-exempt fund. So reading this graph, 1 month out, we can expect to have 61% of that initial $1 million still invested at Putnam. That's approximately $606,000. If we keep looking at approximately 6 months out, we're expected to have 28% of those assets remaining. And then if we look at 12 months out, we're expected to have 22% remaining. So that's how you read this graph. What we really want the business to do is flip through these different parameters that they've selected and see how that changes over time. So I'm going to flip to a different fund and just keep your eyes on the graph to see what changes. So we go to the Cowboy Fixed Income Fund. You'll notice that the curve shifts up on the y-axis, but it's also a different shape. So looking at this, you can definitely make some assumptions about how funds may impact the customer behavior. 1 month out, dollars invested into this fund, we're still expected to have 90% of them within Putnam. If we look 6 months out, we're still expected to have 53%. So you can start to see some of the value here where your business analysts will say, wow, there's definitely some driving factors behind fund that determine customer behavior. So let's take a look at our last fund here, the Spurs Equity Fund. And again, you'll notice that this curve is pretty similar to the last one, but it definitely shifted up on the graph. What you'll notice here is that 12 months out, we're still expected to have 60% of the assets on the books. If I go back to that other fund, the Cowboy Fixed Income, 12 months out, we're only expected to have 24%. So the retention period between fund is pretty significant. So let's take a look, see if we can determine if firm plays into this at all. So if I switch to the San Antonio Advisors firm, the curve stays pretty consistent, the shape of it, but the assets shifted down on the y-axis. So I would be able to think that the survival is driven significantly by fund for the shape of the curve, but the retention is definitely, firm plays a factor into it. So again, looking at 1 month out, we have 73%, 6 months out, 38%, and 12 months out, 16%. And then if we look at the last fund, the Spurs Equity Fund, again, the curve is pretty standard based on the fund. It just shifts based on the firm. So let's take a look at the last parameter here, which is the age of the customer. So right now we're looking at a customer who's 18-year-old. And in order to really see the change here, I'm going to go to the two dramatic ends of the spectrum here. So if I go to an 85-year-old customer, and let me just do that again and keep your eyes on the graph. So 18 to 85. What you'll notice here is that these 6 months out are what's changing. The first 6 months are pretty consistent between the two ages. So the assumption there is that age doesn't really play a factor for the first 6 months, but something happens after 6 months that customers start to behave differently based on age. So at this point, really the big win here with this what-if scenario is it allows your business to run through these different models to understand the data without having to go through and go any coding. We've really built something that's hands-off that the business can take and run with for a while before they come back and ask for anything else. We've run into scenarios where the business will ask for something and we give it to them, and a week later they're like, actually, we changed our mind, we want this. So this idea of a what-if tool is something that we've instilled to really help them, give them the power to walk through the different scenarios and analysis that they need. So going back to our PowerPoint, at this point we've gone through our case study. So of the assets on the books, thank you, today, how much do we expect to retain at a given period? We've determined, based on our research, that survival analysis was the best approach to solve this problem. We used Python to create the model. We imported the model from Python into Tableau. We built the parameters and the survival function, and then built this user-friendly dashboard that, again, it really allows the business to run through and interact with the model without going through all those coding changes. So at this point, we'd like to open the floor up for questions. If you guys have this survey too, we'd appreciate if you complete that. But yeah, what questions do you guys have? Yeah.
So your model, does it take into account various subscription or redemptions over time, or is it just I put money in and then at 12 months I had the full redemption?
Yeah, so the question is, does the model take into account subscriptions and redemptions over time? So this model does not. So this is not looking at the stock market and not looking at new sales.
I think another part of your question is probably like a partial redemption, maybe. So
Sure.
Does someone invest $1 million and do they take half of it out or something like that? So this model is kind of naive to that. So there are a lot of things we don't include in the model, but fundamentally we're looking at each purchase event and how long that purchase event persists, and there's no decay at the purchase event level, basically. Yep.
What are the actions you're looking for the user to take? Is it that they have a customer who's maybe 6 months out and they need to make a decision, or is it a new customer and they want to recommend a strategy that will end up with an optimal solution?
Yeah, I think the second, we should repeat the question. Yeah. So the question was kind of, how does this drive a business decision? What is someone going to do after interpreting this model? And I think your second point was a big one. And from a kind of marketing funds to customers kind of perspective, we know that profitability is dependent on assets being on the books for some period of time typically. And it's more advantageous to sell a fund in which we would expect customers to stay in it longer, as opposed to a fund where we know that in 6 months, people are probably going to pivot and take their assets out of that fund or something like that. So I think the latter's kind of where the focus is. This is still pretty new. We're just kind of starting to play with this stuff at our organization. So we haven't really gotten to see the full value quite yet, but.
When you're working with more data points, so you have like 3 or 6 firms,
Mm-hmm.
have you tried like pivoting the data, but also you have it like more in a row format that gives you like more flexibility with comparisons, or do you like leave it in the column format? Have you found like this is a better approach?
Yeah, so the question is, have we tried pivoting the data to try a more column format instead of a row format? So we haven't, actually. That's a pretty interesting thing that we could try. One thing that we have done is we tried using models like this to build into a forecasting model, which was a lot of fun. It was a lot more Python work and it's kind of outside of the Tableau realm, but there are definitely a lot of possibilities. But yeah, good suggestion though. Oh, I'm sorry, I can't hear you.
Have you considered bringing any external or macroeconomic factors into your model to see why?
Yeah, it's definitely something comes up. Or keep forgetting to repeat your questions. I'm sorry. So the question was, have we considered adding economic factors into our model? So maybe market fluctuations, I know the S&P, something like that. So it's something we could, it's something we're not doing. It makes the modeling significantly more complex, especially because if you think about a market, that's something that varies over time. So a purchase into some fund, the fund doesn't change over the lifespan of that purchase. The value of the S&P or whatever that fund is benchmarked against is constantly changing. So if you're interested in it, there's a lot of information in the Lifelines package. If you go on their GitHub site, they do have some support for models like that, but it's much more complicated. Oh, you can go. Yeah, so the question is how it's going using this kind of stuff for forecasting. So it's something we're actively working on. It's tough. It hasn't been super accurate so far, but it's showing a lot of promise. We kind of built our approach off of a white paper we came across online that I can share with anyone if they leave their email address or something, of kind of working backwards after you have your survival function. How do you kind of apply this thing? One kind of challenge you have with that is of the assets you currently hold, they all have different ages, right? So you may have had something on the books for 3 years already or something like that. So you don't want to take all of those assets and just apply them to the curve and say, okay, next month we're going to drop by 15% or something like that, because those assets may have already experienced that initial risk and they might be in a flatter part of the curve or something. So we did try it. It ended up being a lot of Python work, and we're still kind of messing around with that, but good question.
Visually, instead of just looking at the one fund at a time and then remembering,
Mhm.
the San Antonio one was better than Bonnie and Clyde. Do you sometimes show them, make fun the color and then overlay them with each other?
So the question is, do we ever show multiple funds at the same time, multiple firms at the same time in different colors for comparison? So the answer to that is we haven't been doing that, and the reason is because there are kind of statistical approaches to that, like the log rank test and things like that, that are designed for like hypothesis testing of survival curves, essentially. So what we wanted to make sure we were not doing is making it almost too clear for the user, so they're saying, oh, this curve's a little higher than this one, therefore we know it's better. One big limitation here is that we're not showing confidence intervals or anything like that, so it's kind of dangerous to start exposing it like that so they can really make those comparisons. At this point, it's just kind of you can get a general idea. You definitely look at the shapes more than directly comparing, but good question.
Did you find Lifelines to be mature enough to use like this? Did you consider an R package or just doing Kaplan-Meier right inside of Tableau?
Yeah, so the question is, in working with Lifelines, did we find the package mature enough to build stuff out like this? Why didn't we choose R? Or just do Kaplan-Meier right in Tableau? So a few things on that. So Lifelines is definitely not quite as mature as a lot of our packages designed for survival analysis, so that was kind of a limitation. We kind of experimented with a lot of our packages as well, but our core competency is mainly in Python, so it made a lot of the work easier to do in Python. So Kaplan-Meier, that's actually what we ended up using for the forecasting approach. So instead of having this one model with all these regressors, what we did is we broke it down by fund and firm and sometimes even by channel, like line of business, and did Kaplan-Meier with you don't have any covariates at that point. So we wanted the flexibility in Tableau, but ended up for kind of a more productionalized process using Kaplan-Meier.
How do you communicate this to the people that you share with? What kind of story you guys have in the way?
Yeah. So the question is, how do we communicate this to the people that we're sharing with it? And we have a very good relationship with our business. So before we came up with survival, we did a lot of research on our end to make sure that that was something that worked. We worked with the business to make sure they understood why we chose it. They didn't necessarily understand the model or what the survival function is or the cumulative hazards. But keep in mind, this was more of a proof of concept to give them something, a different way to look at their data and to understand it. So they had a basic understanding of survival and why we chose it and why we felt it was the right way to use it. And the story behind it is really was just a different way to visualize the data, to look at the data. Putnam, I'm sure you guys all have a ton of data at your company, and there's a ton of different ways to look at it. This was a question that came up, and they wanted to see how we can come up with something to try to understand what the risk is over time of losing assets.
And an important thing to add there is that was a big part of the motivation for shifting to a forecasting approach, because when you're doing a forecast, you don't really have to explain this kind of stuff. You're saying, we expect this much of the assets to be here X number of months out, and you're already doing that upfront work of working with your data, and you're just outputting dollar amounts, basically. So that's kind of why we're going in that direction with it.
You said you did a lot of research and everything before you dove in, right? So how long would you say this took from the time the question was posed to where you had some kind of working model?
Yeah, so the question is, how long did this take from kind of inception? We were asked the question, and we tried different approaches and came to this solution, I think. So it wasn't something that we were kind of actively working on every day. It was kind of so it's tough to say it in months or something like that. But I mean, part of the problem is we tried a lot of things that didn't work. So like the first thing we tried was using machine learning stuff in scikit-learn, so random forests and that kind of stuff, to say, okay, which purchases do we think are going to redeem next month or something like that. So technically, that was a classification problem. And so we ended up with something that isn't classification, basically. We're predicting duration, or not durations, but ratios, essentially. So I think the question kind of matured a lot over time. We found that our model wasn't very good at predicting what was going to happen next month because mutual funds are such long-term investments. I mean, if you just kind of naively look at it without like a confusion matrix or something, you'll be at nearly 100% accuracy, saying that 100% of the assets are still going to be here, because such a small subset move over a month's period of time. So yeah, I don't know if that totally answered your question. It took a little while, several months, but also this was kind of not on the forefront. So.
And just to add to that, we follow a Scrum project methodology, and we have a pretty rigid standard around our forecasting and our approach to problems like this. We work in 2-week sprints, and we'll pull something like that. And there's a ton of communication on the team where we're constantly getting together, every other day, every couple of days, to say, all right, we tried this didn't work. Let's talk about it as a team and decide the next approach. So it's not like one person's just going off and doing it on their own. That's something that really works well for us.
Sorry, this is easy to armchair quarterback this, but if you have this model come out and one fund seems to be the big winner, and then you have a herd move where everybody moves over, are you guys like refreshing this model frequently? Because if all of a sudden they get a whole new population moving over there, it's got to change. I would guess it would likely change the way that curve looks.
So the question is, are we constantly refreshing this model, because if we try and sell this fund to people, are they all jumping in this fund, and now the behavior of this fund we'd expect to be different? So I think that's a good point, and we've even seen this based purely on kind of market performance and things like that. There are funds that classically have done really well, so we expect them to be really persistent. We expect the graphs to be kind of flat, but they have a bad year or something like that, and now your estimates are way off. So We don't do a whole lot of refreshing on it. You kind of just take it with a grain of salt. You also have to approach it from a perspective of this is just one piece of information in your business, kind of, but that's a good point, and that's a problem that we definitely hit with it.
How does the model generation scale? So if you have larger volumes of data, how long does it take to generate a model and that sort of thing?
Sure, so the question is how does the process scale? So does it take a long time if you have a lot of data, essentially? It's pretty good. I can't remember any numbers off the top of my head, but I have used more than 6 records before. I don't think I hit any issues with, I don't know, maybe tens of thousands or maybe 100,000s of records. But so in short, it's not too bad, but I wouldn't use it on big data volume, not to use a buzzword or anything, but there's definitely kind of a point where things slow down. Yep.
How do you know your questions are answering the business's needs, and how do you go about scoping out the project before to the end of the project?
So the question is, how do you know that the questions are answering the business needs, and how are you scoping it out? Like I said, we follow that Scrum project methodology, so the business is kind of right beside us the entire time and giving their input. There's a lot of communication and interaction. As Dean mentioned, the question changed over time. The business kind of comes and says, how much are we going to have in 6 months? And you really have to try to understand what that means. So there's a lot of discussion and really getting the business to understand what the data set is, and just trying to understand what they're looking for. Communication is the big thing. Like, they're always working with us.
Yeah, I think that's a good point, and I think it's almost to the developer's benefit to have a conversation about what's working and what's not working. For example, if you're doing survival analysis, a popular thing to report is the median survival time. So at what point do you hit 50%? But we have, so the examples we showed were very extreme, right? We had some things going all the way down to 15% or something. We've had cases where it doesn't hit 50%. So you can't report the median because more than half of the population is still alive. So in that case, there's not really much you can do. So it's a good opportunity to discuss with the business and say, you know what, this metric we thought was going to be good, but we're not going to be able to get it for 85% of our funds. So we should really think about a different approach. Yep.
So the question is, how many people do we expect to use it? There's about 5 or 6 right now at this level. This will go into the forecast, which will be used by the bigger masses. But this is just one small piece to the entire puzzle. But about 5 or 6 people really diving in and looking at it, including our team too, just to try to get a better understanding, so we can build our knowledge on the business as well.
Yeah, so far so there's definitely that forecasting piece that a lot of people will touch, but we've done kind of one-off Kaplan-Meier survival stuff as more strategic things. Like someone has a question now and they say, how is the survival in 2016 different than last year or the year before or something like that? So in that case, it's only a couple people are seeing it, but it's being delivered to the person who can act on it, basically. So
who would be responsible for maintaining the dashboard over time?
So we keep that, the question is who's responsible for maintaining the dashboard over time, and we keep that within our group. We refresh the data sets. We have a very strong ETL background, so a lot of it's all automated data refreshes and extracts.
Yeah, we actually initially planned to show the extract API a little bit in this talk, but the volume of data we were showing is so small. It was 12 records. It's kind of, don't get a whole lot of benefit from that, but we have used that before. And it's definitely something you can use. Because you're doing a lot of this work in Python already. You're doing the model generation in Python, and Tableau has a great API for making an extract out of your data. So if you wanted to automate it, you could just do that all in Python, and your extract would appear in the folder you want it, and it should be pretty easy.
I guess keep in mind too, with technology changing and we're constantly learning new things, that this may work for 6 months or a year, but then we may come up with a better solution to solve the problem or a different question that we need to focus on. Any other questions? All right, thanks guys for coming out today.
Thank you.